15 years ago, as a Japanese spacecraft quietly orbited the moon, snapping endless images of its cratered surface, it captured something no one expected. Amid the familiar circular imprints left by ancient impacts, one particular feature stood out. It wasn't a crater at all, but a strange, shadowed void. A deep, dark hole descending straight into the moon's interior. It looked out of place, almost unnatural. And it sparked a question no one had seriously asked before. What lies beneath the moon's surface? That question would echo through the halls of planetary science for years. Since that first discovery, orbiters from multiple space agencies have identified over 200 similar holes scattered across the moon. Each one seems to open into the darkness below, a potential entrance to a network of hidden tunnels. These aren't just curious geological quirks, they are possible gateways to an alien underworld, a landscape untouched for billions of years. And now, those holes have taken center stage in a new chapter of the space race. Because one country is moving fast to explore them. And that country is China. Despite international criticism over its handling of recent space missions, like the uncontrolled re-entry of a 23-ton rocket booster from its Long March 5B, which crashed into the Earth's atmosphere in 2021, China has become an increasingly dominant force in space. The Tiangong space station is fully operational and crewed by takonauts conducting long-duration missions. Its Chang'e lunar program has already delivered lunar samples back to Earth. These successes have made it clear, China isn't just participating in space exploration, it's aiming to lead it. In May 2023, China announced an ambitious new objective, to send humans to the moon by 2030. But not just to plant a flag and take a few photos. China intends to establish a permanent human presence, a lunar foothold that could become the foundation of deeper exploration and long-term habitation. While the final landing sites haven't yet been publicly confirmed, scientists and officials have hinted that some of the most likely candidates include areas with these strange holes, especially those in the Mare Tranquillitatis region. What is it about these seemingly bottomless pits that would make them attractive destinations for human exploration? What's hiding beneath the moon's ancient crust, and why does China want to be the first to go in? To understand that, we need to travel back billions of years to when the moon was a very different place. In its early life, the moon wasn't the cold, silent desert we see today. It was alive with volcanic activity. Molten rock spewed across its surface, creating vast oceans of lava that shimmered under the young sun. As these rivers of fire flowed across the landscape, their outer layers cooled and hardened first, forming a crust. But beneath that shell, lava kept moving, tunneling its way forward and carving out hollow channels beneath the surface. When the volcanic activity eventually slowed and the lava drained away, it left behind enormous underground passageways. On Earth, we call these lava tubes, and you can find them in volcanic regions like Hawaii or Iceland. Here they might stretch for hundreds of feet. But on the moon, where gravity is just 1/6 that of Earth's, these tubes could be absolutely colossal. Some are believed to be hundreds of meters wide and dozens of kilometers long. Natural caverns, preserved in time, untouched by meteor impacts or erosion, still lie just beneath the surface, hidden in plain sight. Over the eons, sections of these ancient tunnels have collapsed. When the ceilings gave way, they formed open pits on the moon's surface, what scientists now refer to as skylights. These skylights are not the remnants of impact craters, they're windows into the deep interior. And thanks to satellite imaging and radar mapping, we now have increasing confidence that many of these pits connect to vast, intact lava tubes. Take the Marius Hills skylight for example, one of the most studied of these features. The Japanese Selene orbiter, also known as Kaguya, used radar to bounce signals into the pit. The results revealed something stunning, an echo signature that could only come from a large, hollow chamber underground. It was a ghostly voice from the moon's interior, confirming that the tunnel was real. Later, NASA's Grail mission, by measuring tiny variations in the moon's gravitational field, pinpointed areas of lower density, consistent with empty underground voids. When these two data sets were compared, they matched perfectly. It was now more than theory. These weren't just holes. They were entrances. To the global scientific community, the implications were thrilling. These lava tubes are not only a geological treasure trove, offering a perfectly preserved record of the moon's ancient volcanic past, they might also hold the key to our future in space. Because while the moon has always fascinated us, it's also tried to kill us. The surface of the moon is one of the harshest environments in the solar system. There's no atmosphere to protect against radiation or micrometeorites. Solar storms can hit without warning, flooding the surface with deadly radiation in minutes. Daytime temperatures soar to 250 degrees Fahrenheit. At night, they plummet to -200. No life as we know it could survive these conditions for long. And even the toughest machines struggle against this brutal swing in temperatures and the constant barrage of space weather. For any long-term human mission to succeed, we need protection, real, physical shielding from the hostile vacuum outside. That's where these lava tubes come in. Imagine stepping into one. The harsh glare of the sun disappears behind you. The silence deepens. You're inside a cathedral of ancient basalt, protected by thick rock walls that absorb radiation, deflect meteoroids, and maintain a far more stable internal temperature. In fact, measurements from NASA's Lunar Reconnaissance Orbiter suggest that temperatures inside these tubes remain astonishingly constant, around 63 degrees Fahrenheit or 17 degrees Celsius. It's almost comfortable. No wild fluctuations, no blazing heat or bone-freezing cold. Inside a lunar lava tube, it's as if nature carved out a ready-made bunker for us, an oasis beneath a deadly sky. These natural shelters could save us countless tons of construction materials and years of effort. Building a habitat inside a lava tube means not having to erect massive radiation shields or dig protective trenches. Instead, we start with a structure that's already there. Some of these tunnels are wide enough to fit entire city blocks. You could construct living quarters, laboratories, storage bays, and life support systems all within the safe confines of this natural cave. And that's exactly why China is interested. Not just for the scientific value, but for the strategic advantage. A nation that controls access to these lunar tunnels could, in theory, establish the first permanent base on the moon with relative ease. It would be shielded from the elements, safer for long-term human occupation, and ideal for launching future missions deeper into space. Mars. The asteroid belt. Even resource extraction could begin from within these bases. It's no longer just about planting flags. It's about staying. And that raises another layer of intrigue. Because as nations like China, the United States, India, and others look to the moon with new ambition, it's not just about exploration. It's also about territory, resources, and survival. Lunar water ice, discovered in shadowed craters near the poles, could be turned into drinking water, oxygen, or even rocket fuel. Helium-3, a rare isotope believed to be abundant in lunar soil, has been touted as a potential clean energy source. And these underground lava tubes? They're starting to look like prime real estate. Which leads to an inevitable question. What happens if someone gets there first? China's timeline is aggressive. A manned lunar landing by 2030. Crewed missions scouting the surface. Robotic explorers analyzing the holes. Site surveys underway. And if their Chang'e missions are any indicator, China has the discipline, resources, and technological capability to pull it off. These mysterious holes, these portals to the past, might soon become stepping stones to the future. And China intends to take that step before anyone else. The race to the moon is no longer theoretical. It's happening now. And the secret caves beneath its surface, quiet, ancient, and waiting, might just become humanity's next frontier. And even manufacturing facilities, all safely tucked away from the deadly hazards of the lunar surface. But protecting astronauts from the moon's deadly environment is just the beginning. What if we could go further, transforming these shadowed, silent voids beneath the surface into something more than shelters? What if we could turn them into fully livable, breathable homes? The idea isn't just science fiction. Scientists are now seriously exploring the possibility of sealing off these caves, pressurizing them with an Earth-like atmosphere, and creating habitats that feel familiar, air you can breathe, temperatures that don't boil or freeze you instantly, and structures shielded by up to 50 feet of solid lunar basalt. That natural shielding is crucial. It means astronauts wouldn't need to haul up tons of heavy protective materials from Earth or design bulky surface modules to resist micrometeorite impacts and relentless cosmic radiation. The lava tubes offer a ready-made solution, a cosmic gift hidden in plain sight. Instead of building on top of the moon, we build inside it. And if we can stabilize and seal those cavities, we gain a reliable, safe interior that mimics the comfort of home. These internal sanctuaries could become the beating heart of a long-term lunar colony. But comfort isn't the only benefit. These controlled environments would also provide a stable thermal zone, shielding inhabitants from the violent temperature swings outside, swings so brutal they would render traditional farming nearly impossible. But inside the cave, conditions remain far more consistent. That means we could potentially grow food underground, using hydroponics or even advanced aeroponic systems. Instead of importing every calorie from Earth at enormous cost, lunar settlers might cultivate leafy greens, nutrient-rich vegetables, or even algae within artificial sunlit chambers, perhaps powered by mirrors and solar collectors on the surface. This is where the vision expands beyond exploration. A pressurized, food-producing, resource recycling base inside a lava tube would be more than a science outpost. It would be a colony. A self-sustaining, long-term foothold that doesn't rely on earthly supply chains. And with every resupply flight we don't need to launch, we get closer to making lunar living not just feasible, but practical, even economical. Just imagine it, stepping into a vast cavern lit by artificial skylights, the air breathable, the temperature steady, the walls humming softly with the sounds of life support systems. You'd be walking on lunar dust under artificial gravity simulators or possibly floating freely in that eerie, light-as-a-feather 1/6 gravity. Sports would be surreal, like playing basketball on a trampoline in slow motion. Every jump would become a graceful glide, every tumble a float. What kind of games would people invent in this new world? What would recreation even look like on the moon? But before we begin carving out lunar suburbs and organizing zero-gravity tournaments, there's a critical hurdle we can't overlook. No one knows exactly how stable these caves are. Are they truly safe? Or are we romanticizing an environment that could collapse without warning from a seismic moonquake? Before we build, we must explore. And before we explore, we must innovate. That's where the cutting-edge technology comes in. Because reaching down into these dark pits, descending into tunnels where no human has ever gone, requires machines that can go where people can't. NASA's Jet Propulsion Laboratory is at the forefront of this frontier, designing the remarkable Duaxel rover. It's not a traditional rover, it's modular, splitting into two. One half remains safely anchored at the lip of a lunar pit while the other is lowered by cable down into the abyss. Hanging like a scientific spelunker, the descending module uses high-resolution cameras, laser rangefinders, and spectral scanners to study everything it sees, every crevice, every layer of rock, every possible path forward. But Duaxel isn't alone. A team at the University of Würzburg in Germany has developed another robotic pioneer, Daedalus. This small, spherical bot is about the size of a basketball and it doesn't need wheels. It rolls, it spins, it navigates with remarkable precision through tight corridors and unpredictable terrain. Using LiDAR, it bounces lasers off the cave walls to create stunningly detailed 3D maps, data that not only reveals the shape of these ancient tubes but exposes their structural secrets. With these scans, we'll know how deep the tunnels go, whether the ceilings are crumbling or intact, and where we might one day build our first homes. But perhaps the most radical explorer is a hopping robot, literally. At ETH Zurich, researchers are working on Spacehopper, a robot designed to bounce across the lunar surface and leap into craters or lava tube entrances. No wheels, no treads, just pure, calculated motion. In the moon's low gravity, this method of movement allows Spacehopper to cover rough ground that would disable conventional rovers. It can jump into pits, gather footage and environmental data, then leap back out, like a futuristic lunar frog. Its successful tests in zero-gravity conditions on Earth suggest it may soon become one of humanity's first true lunar cave explorers. The importance of this technology can't be overstated. Before we even consider laying the foundation of a lunar city, we must know, truly know, whether these caves are safe. A collapsed habitat, triggered by a moonquake or a weak section of tunnel, could be catastrophic. The data from Duaxel, Daedalus, and Spacehopper will tell us where it's safe to build, where we must reinforce and where we must simply stay away. And while NASA and its partners push forward, they're not the only ones in the race. China is moving fast, perhaps faster than anyone anticipated. With its state-backed Chang'e missions, it's already proven its ability to soft-land rovers and even return samples to Earth. Now, it's planning a new wave of lunar pit exploration using partially tethered robots with advanced imaging systems. Similar in ambition to Duaxel but developed in-house, on their own terms. Their goal? Map the caves, analyze the structures, stake a claim. And those stakes are high. These lava tubes aren't just shelters. They're vaults of untapped resources. Deep inside their walls, locked in the ancient lunar rock, could be reserves of helium-3, a rare isotope believed to be a potential game-changer in nuclear fusion. If fusion power becomes viable, helium-3 from the moon could become the clean energy source of the future. And whoever controls that supply, controls the future. There may also be deposits of water ice, especially in shadowed craters connected to lava tubes. Water isn't just essential for drinking, it's oxygen and hydrogen, air and fuel. If we find enough of it, lunar bases could produce their own air and power their own rockets. We'd no longer be launching from Earth. we'd be launching from the moon. Mars, the asteroid belt, even Jupiter's moons would suddenly be within practical reach. All because of what's hidden inside these ancient caves. We are, without question, living in a new space race. But it's not like the last one. This time it's not just about planting flags. It's about staying. China is investing in long-term strategies, targeting permanent settlement by 2030. Their approach is methodical, backed by government funding and 5-year plans that stretch decades into the future. Meanwhile, the US is adopting a more hybrid model. NASA working with private partners like SpaceX and Blue Origin to harness innovation, lower costs, and move fast. SpaceX's Starship could deliver heavy equipment and habitats in a single launch. Blue Origin is working on its Blue Moon lander. Both are aiming at building not just missions, but economies. Lunar mining, lunar tourism, lunar construction. The moon is no longer just a goal. It's a starting point, a launch pad, the gateway to everything else. And through all of this, the caves remain central. They offer the only natural shelter for humans on a world that is otherwise harsh and hostile. And in a strange twist of fate, they connect us to something deeply human. Because this isn't the first time we've sought refuge in caves. Tens of thousands of years ago, early humans found safety beneath the earth. Hidden from predators, from storms, from the cold. Caves were sanctuaries, the birthplace of art, community, and survival. And now, thousands of years later, as we look to colonize the stars, we return to that same instinct. To hide beneath the surface. To build in the shadows. To turn darkness into shelter. It's a poetic symmetry. Our past, our future, connected by the quiet stone hollows we call caves. And someday, when future generations walk through the echoing chambers of a lunar city, they may look up at the jagged basalt ceiling and remember. This is where it began. Humanity's first step toward living among the stars wasn't on the surface of the moon. It was inside it. And yet, this lunar chapter is only part of a much bigger story. Because while China reaches for the moon, it's also digging into something even more mysterious, our own planet. In a bold and secretive project, China is now drilling one of the deepest holes in Earth's crust. What are they searching for? What secrets lie beneath our feet? And how might this extraordinary earthbound mission tie directly into China's ambitions in space?